This section examines the electronic control unit. The electronic control unit receives signals from different sources. A switch at the brake pedal provides a brake operating signal. Another in the ignition system signals the engine is operating. This sets off the automatic check the ABS conducts every time the engine starts. Another input is from the wheel speed sensors. These signals are used to control the hydraulic control unit and anticipate wheel lock. If a wheel starts to lock, the electronic control unit operates the solenoid valves to reduce hydraulic pressure appropriately. This section examines the hydraulic control unit or modulator of the anti-lock braking system. The ABS control module or ECU sends commands in the form of electrical signals to the hydraulic control unit. This unit executes them using 3 solenoid valves connected in series with the master cylinder and the brake circuits. 1 valve for each front wheel hydraulic circuit and 1 for both of the rear wheels hydraulic circuit. This is a simplified diagram of 1 solenoid valve operating on just 1 wheel. In normal, non-ABS braking, brake pedal force is transmitted to the master cylinder, then through the solenoid valve to the brake unit at the wheel. The signals from the wheel speed sensor show no tendency for the wheel to lock up, so the ECU is not sending any control current to the solenoid coil. The solenoid valve is not energized, and the hydraulic pressure from the master cylinder is supplied to the brake unit at the wheel. When the control unit detects any lock-up tendency, perhaps from too rapid wheel deceleration, it sends a command current to the solenoid coil. This causes the armature and valve to move upward and isolate the brake circuit from the master cylinder. That keeps the pressure between the solenoid and the brake circuit constant, whether or not the master cylinder hydraulic pressure rises. If the sensors signal continuing excessive wheel deceleration, the control module sends a larger current to the solenoid valve. This lowers the braking pressure by moving the armature up further, opening a passage from the brake circuit to an accumulator, a temporary reservoir for any brake fluid that flows out of the wheel brake cylinders because of the fall in pressure. A return pump sends this brake fluid back to the master cylinder. If the sensors then signal the lower pressure has let the wheel speed up, the ECU stops all command current, which de-energizes the solenoid valve. The pressure rises and the wheel is again slowed down. No matter the phase of operation, pressure in the circuit can never rise above master cylinder pressure.